9.4 objective. Learn to find and use mean, median, and mode to draw conclusions and make predictions. Essential question, how does changing a data point impact the mean and median? Vocabulary terms that we will go over. Measures of central tendency are used to describe the middle of a data set. Mean, median, and mode are measures of central tendency, the 3 M's. The mean. To find the mean or the average, add the values in the data set, then divide by the number of values in the data set. Median, the middle value, or the mean of the 2 middle values in an ordered set of data. Mode, the values that occur most frequently. A data set may have no mode, one mode, or several modes. And range, which is not a measure of central tendency, it's just an additional piece of information, is the difference between the least and the greatest values in a data set. There needs to be a way for you to remember which one's which. Mean is the average. Think of mean as the mean one because it makes you do more work. You have to add all the numbers and divide. It's multiple steps. Median and middle both have a D in the middle of their words. So that's one way I remember that the median is the middle. Mode and most have the same number of letters. Just remember most means most frequently occurring, not the highest. And the range, again, just how far does it go? An outlier is a value that is either far less than or far greater than the rest of the values in the data. Let's start by identifying the outlier in the data set and determine how the outlier affects the mean, median, mode, and the range of the data set. If you look at all these numbers, there's one that stands out, and that number would be 51. We would call 51 an outlier because the next closest number is 32, and 51 is nowhere near any of these. The distance that the outlier will be away from the other numbers is not a set number. It depends on how tight the other numbers are together. It also depends on how large the numbers are or how small they are. These have all been calculated for you. These are the same numbers that you just saw on the previous slide. With the outlier included, the mean would be 30. 210 is the total of all the numbers added up, and there are 7 numbers, so we divide by 7 to get 30. The median is 28. Once we put the numbers in order, least to greatest, and find the middle, we find out 28 is the middle. The mode is both 21 and 28, and the range somehow disappeared here, but 51 minus 21 is 30. Same as the mean, but totally unrelated to the mean. So if we look at where the mean fits in terms of the data, the mean would be almost near the end. So if we had to choose which one of these is a better measure of the middle, we can narrow it down to either the mean or the median. The mode isn't very good for measuring the middle because if you notice, 21 is one of the modes, which is the last 2 numbers in the set, the lowest. So we don't want to use the mode, and range is not a measure of the center. So we have 2 options. So we look at 28 as a middle, we look at 30 as a middle. To me, it looks like 28 is closer to the center of all the data. 30 is higher because of the outlier. If we change the outlier to a number closer to the rest of the data set, 30 is going to become smaller, closer to the 28 mark. If we change 51 to anything else, the median isn't going to be affected at all because no matter what number you have here, it's just a placeholder. So let's look at the outcomes when we take the outlier away and then summarize. Without the outlier, our mean is 26.5. Nothing else changes except for the range, and that just shows that our data is not closer together. The median happens to stay 28 because there are 2 28s in the middle. So to summarize, the outlier increases the mean by 3.5 and the range by 19. It has no effect on the median or modes. Therefore, we can summarize that the median is most useful when the data set has an outlier, and the mean is most useful when the data set does not have an outlier. Focus on the mean and the median. The data set does not have an outlier, then you want to use the mean. If the data set has an outlier, choose the median. Mode, unless they specifically are asking for showing the most frequent or the mode specifically, don't choose mode. And range, again, is not a measure of the center, but you would use the range to show the spread of the data. Make sure you have the mean and median in your notes and when to use them. So let's make some determinations. Determine and find the most appropriate measure of central tendency for each situation. Justify your answer. Competitors receive the following scores for their performance in a gymnastics competition. You can see the values given. What measure best describes these scores? Without doing any calculations, do we see an outlier? Yes, we see an outlier of 0.8. Now with that outlier, because it's there, without calculating anything, we know the mean is going to be lower than it should be, but the median should be close to the middle. So because of the outlier, we want to use the median. If we actually organize these least to greatest and find it, the median is 8.7, and that would best describe the scores. Let's look at another one. Employees at a store earned the following dollar amounts during 1 week. Which measure would make the salaries the highest? So would we want to find the mean, the median, or we could possibly do the mode? If you look through those values, it doesn't really look like there's much of an outlier. So if we find each one, 317, 309, and there's no mode. Now that we have all options, when we're looking to which one would make it the highest, we would choose the mean because it's 317 where the median is 309. The mean is greater than the median, would make the salaries the highest. The last part about this, and this is a little bit beyond the basics of mean and median, is a weighted average. This is also how most of your grades are calculated in your classes. It is a mean that is more strongly influenced by some data values than others. For example, in our math class, your tests and quizzes are worth a higher percentage than your homework, so it's weighted. Slugging average is something many of you have heard of. It is a weighted average used in baseball. To calculate a slugging average, use the following weights. 4 points for home runs, 3 for triples, 2 for doubles, 1 for singles, and 0 for outs. What is Zoe's slugging average to the nearest 1,000? So we take how many of each category Zoe got and we multiply by the number of points it's worth. So she had 3 home runs, which is worth 4 points each. She had 2 triples, which is worth 3 points each. 5 doubles, worth 2 points, 13 singles, worth 1 point, and 44 outs, worth 0. We still include the 44 because that's going to be part of our total when we're dividing. Now we don't divide by any of the weights, but we just divide by how many total at-bats she had. So we add the 3, the 2, the 5, the 13, and the 44. Once we calculate this, we get 41 out of 67, which is a 0.612 slugging percentage. That's it. Make sure your notes are filled out completely, including those questions on the left-hand side. When you're done with your notes, give it a day, come back and complete the summary.